I would just give you a small brief and then introduce you to our panelists for the session. This session is all about national framework for space sustainability, advancing policy, innovation, and global collaboration. A short brief is about you join SIA-India and Nabhah Foundation for this dynamic session, uniting policymakers, industry leaders, and global experts to accelerate India's role in securing Earth's orbits. This session convenes leaders to launch working groups, publish a national white paper, and drive global partnerships for debris mitigation and regulatory alignment. Together, we accelerate India's leadership in sustainable space ecosystems and turn collaboration into concrete action. This is going to be a great session indeed. Let us just invite our moderators and panelists for this session. We will have a short video message from Ms. Aarti, Director UNOOSA. Then we have Dr. A.K. Anil Kumar, ISTRAC, and ISRO System for Safe and Sustainable Space Operations Management. Then we have Professor Dr. Kai-Uwe, President of International Institute of Space Law, Dr. Sudharshana, Ramaraju, founder of Nabhah Cosmos Foundation, Ms. Aya, Director, Japan Space Policy, Dr. V.S. Hegde, former Scientific Secretary, ISRO and CMD Antriksh, Dr. Benisha P. from International Institute of Waste Management, and Mr. Tanveer Ahmed. I invite you all to please be on the dais and start with the session. Before that, we will play a short video message. Thank you.
Everyone, and namaste. My name is Aarti Holla-Maini, and I'm Director of the UN Office for Outer Space Affairs. My thanks to SIA-India and the Nabhah Cosmos Foundation for inviting me to address you here today. As many of you know, I have come to the UN from a career in the satellite industry. That is a very different environment where impact and results count a lot more than just activity and momentum. When we think about space sustainability, there is a lot of activity and plenty of momentum. In any given year, there are multiple events where the same topics are discussed again and again. I have three problems with this. The first is that these discussions become repetitive, going over and over the same issues without really helping us to find solutions to the various challenges we face. They do not take a results-driven approach. The second is that most of the discussions miss the real problem entirely. The long-term sustainability guidelines were adopted by COPUOS in 2019 under India's leadership, but they're not being sufficiently or systematically implemented. The third problem I have is that decision-making on many space sustainability topics are to be taken by COPUOS, the Committee on the Peaceful Uses of Outer Space. That convenes in Vienna, and those delegates do not travel around the world to all the space sustainability events that take place in various countries. In other words, any knowledge, best practices, or valuable exchanges that might happen at those events are not benefiting the real decision makers. It is for this reason that in January this year, my office decided to convene the UN Space Sustainability Days in Vienna, ahead of the Scientific and Technical Subcommittee. We ran a tabletop exercise for COPUOS delegates so that they would have a better understanding of the real-world decisions that operators need to take when faced with conjunction warnings or dealing with debris. Space sustainability issues, from space traffic coordination to debris mitigation and in-orbit servicing and manufacturing, are necessarily complex, technical, and operational. There is a burning need to build capacity of COPUOS delegates so that they are informed and can take the decisions we need to advance on relevant areas of global governance. So what is happening at COPUOS today, and what is my office doing to support it? I want to start with the long-term sustainability guidelines that I'm sure you have at least heard of. We must move from paper to practice. Consider guideline B1 to 5, for instance. One of the major issues in space traffic coordination today is that not all operators share information with SSA service providers or systems. While there are pockets of coordination, for example, those who share data with the EU SST system or with the Space Data Association, this is not a systematic requirement that space regulators impose on operators. Yet, the guidelines suggest that this information should be shared. We hear often that we need binding rules to ensure space sustainability. The LTS guidelines are not binding, but they can become binding if implemented regionally or nationally. Recently, I spoke with a space regulator and asked why they did not include information sharing as a license requirement. The answer I received was that no one had told them to do so, and that this was a matter of policy to be decided on by the space agency. A space agency that had been wholeheartedly involved in the drafting of the very same guidelines. So this is what I mean when I say these discussions are often just missing the point. Are we just complaining and reiterating the problem, or are we actually discussing how to overcome it in a very pragmatic way? Whether it's the space treaties or the LTS guidelines, we should be focusing on how to move from paper to practice and what is it that stands in the way of doing so, rather than just complaining at the lack of binding rules. This is something that UNOOSA is addressing head-on, including at our Space Law Conference taking place later this year. But not all implementation needs to happen nationally. Some things still require very much the multilateral process. When it comes to space traffic coordination, for instance, a proposal was made earlier this year to establish an expert group to look at how to improve data sharing at global level. As your event unfolds in Delhi, COPUS delegates in Vienna are discussing this topic, and we very much hope they will decide to move forward with it. Active debris removal and on-orbit servicing is another topic that can benefit from the consensus at multilateral level. In addition to proactively mitigating debris, we need to foster the creation of a market or find ways to address the market failure. Here, Japan, the UK and New Zealand, countries with hands-on experience in this field, are driving the discussion forward. COPUS should not reinvent the wheel. It should look at how countries like Japan have already done it with their on-orbit service guidelines adopted in 2021 and assess whether guidelines like these can serve as a global best practice so as to accelerate and make progress in a critical area. At the end of the day, it is only through regulatory certainty and transparency that we can encourage more investment into ADR technology solutions. I close by looking at India, a nation that has made giant leaps in what it has achieved in terms of technological development in space over the last decade. Just as India has been bold in its space ventures, I hope that it will also be bold in its Delhi Declaration on Space Sustainability and on what it decides to do nationally. I hope to see guidelines that require operators to become members of the Space Data Association and share information on their space objects. I hope to see guidelines for a license for on-orbit servicing, perhaps aligning with the Japanese approach. I hope to see India do its own technology demonstration and remove a defunct satellite from orbit, perhaps in partnership with another country. But most of all, I hope to see India championing and leading a results-driven approach within COPUS, as we need to accelerate and we cannot keep working in the same manner as we have done for the last 6 decades. The world and space are not the same anymore. I hope that these thoughts were useful to you, and I wish you a very successful conference. Namaste again, and thanks for having me with you.
That was a great message indeed. I would request all our panelists to please be seated in the dais, and we shall commence our session. Thank you.
Thank you, ladies and gentlemen, for coming over here. My name is Sudharshana. I look after a small foundation called the Nabhah Foundation, which has been in existence for the last 6 months or so. This is a non-profit foundation which we founded because we thought there is a big need for space debris conglomeration, mitigation conglomerations. And also we wanted to build a national convergence of institutions, experts, expertise, resources, finances, and various other things in order to cater to this particular domain. There were also many other drivers for this particular thing. One of the first things was just before I founded this foundation, I was chief advisor to the Lieutenant Governor of Delhi. So in many of those banquets, we met a lot of ambassadors who were showing a lot of interest in starting space debris-based institutions in India. They wanted their companies to be here using Indian expertise, Indian talent, and so many other things, which was very welcoming, which was very nice. But at the same time, we thought that we should make use of this opportunity and we should have our own national convergence with the use of our own expertise. And then we came up with this idea of a non-profit foundation, basically because there was a lot of necessities for making this into a movement in the country, conscience-driven movement in the country. With this idea, we just went around the whole place. We went around to ISRO. We met a number of people. Most of the people sitting on the dais, we met them. Dr. Anil Kumar, in fact, was one of the drivers for this particular initiative. He showed us Netra. He showed us all the ideas that ISRO has been pursuing in this particular area. And we met the leadership in ISRO. We met a number of other people, thought leaders, thinkers, big-time experts in space who have retired and who have been pursuing company advisories and such other things. And then we built a status. We built a status paper on what exactly this should be and how we should develop. One of the second driver for that was we were always looking at the idea of climate change mitigation and how the world has been following that, or how the world has been addressing that. You all know that for the last 50, 60 years, or maybe a little more than that, we have had a number of institutions and a number of initiatives that have been trying to address the climate change. We have binding instruments, we have non-binding instruments, we have had conventions, right from the Kyoto Protocol to the Montreal Protocol to the recent Paris Convention, which we have. And each of this has also resulted in a number of national programs, international programs, and international institutions. Most of them are binding. Even within our country, you know that there are nationally contributed, nationally determined contributions, NDCs, and we have a commission for that as well. So everybody has a guideline, everybody has a milestone, and there is a whole world of integrated approach to solve the problem of climate change. In spite of all that, ladies and gentlemen, we haven't solved that problem. We are nowhere near solving that problem, and we haven't understood the magnitude or the dimension of efforts that are necessary for solving the climate change issue. And so the idea of reaching 2 degrees by the end of this century, or 1.5 degrees where we want to be, we are nowhere there. By 2100, we are supposed to have 1.5 degrees increase in the planetary temperature, but we are already there. We are almost already there. This happened basically in spite of all the efforts that we have put in together, institutions, binding laws, and nationally determined contributions, and all the milestones. This has been the case with, this is the combined capacity of human race in addressing one of those very big problems. Now, after discussions with all these people, Nabhah found that the debris problem, the space debris problem, is no less to this. Space debris problem, as you know, I don't have to tell you much about this thing, but the numbers are mind-boggling. The kind of loss of services from space in case the space debris picks up the Kessler syndrome in the next 40, 50 years is enormous. we might be losing billions of dollars. More than all that thing, more than the monetary value of it, we will be losing all the civilizational services. Communication, navigation, disaster management, earth observation, so many things. Many of those things drive our economies, drive our budget, okay, and drive our daily life. And most of that will be gone because we have no control on the space debris at the moment. We do not have a complete understanding of what the problem is, the dimension of the problem itself. And so what do we have? What do we have on board, to control this? We have a lot of efforts that are going on in the world today. We have had IADC guidelines. We have got guidelines which are not binding. We have got a lot of research going on, but huge amount of research is still necessary in the technological areas and also in the regulatory environment. We have to have a lot of research in institutions and concerted effort. We came to understand, or we came to the conclusion that this would not be possible by one institution or a couple of institutions coming together. So we came up with this big idea of national convergence, and that's why we floated this foundation, which is a non-profit-making foundation. The whole idea of national convergence is to bring people together, bring institutions together. And the leading institutions like ISRO, which can guide us, which can provide leadership to this kind of thing. And there are a lot of individual experts who have retired and then gone home. We have already collected more than a dozen of them. Big-time experts who are sitting at home. We have just brought them together on the same platform so that they can be our thinkers. We can try to provide a lot of encouragement and assistance to the industries which are coming up. There are hardly 2-3 industries or a couple of them in this country which are working on this dimension, but there is much more that is necessary here. So there is a whole lot of effort that is necessary. Collaborations ought to be built. Technology barriers ought to be broken because the world has got a capacity of finding out more than 10 centimeters, but less than 10 centimeters. There's a huge gap in the technological domain. There's a huge gap in the technological domain of the satellite-based, space-based efforts to mitigate the debris. So we thought we will try to put people together, collaborations, cooperations, institutions, expertise, experts, resources, finances, all these things. And that is the meaning of the national convergence. So what we did was, I think I will have to read out, we have about 6 foci, the 6 areas, and then we are trying to build a national plan, which is very inclusive of the institutions and individuals in industry, as I said. And these perhaps represent all the areas that are necessary to mitigate, that are necessary to address the issue of space debris. Number 1, refinement and redefinition of the ground-based space debris detection and tracking technologies and efforts. As you all know, it's a very capital-intensive and then technology-intensive field, and those people in the space know that we have got 1 or 2 antennae and MOTR, which costs about 400 crores or so to build infrastructure in the country in order to track the space debris. And so this will also not be, and for the last 4 or 5 years now, ISRO has been working very hard to build this thing. Netra is already there. It's an exemplary initiative, but at the same time, more facilities are not coming up. But at the same time, we haven't, in this country, explored the possibilities of optical tracking. Nabhah went around talking to the people who own the optical telescopes, like the Indian Institute of Astrophysics. And then we have come up with an idea of getting them into the fold where we can use some of those telescopes for not deep space viewing, but the shallow space viewing. And so that is also one of the programs under this particular objective. And the second one is the refinement and redefinition of space-based tracking and monitoring technologies for the detection of space debris. Again, here, this is a virgin area in India. Maybe there are some companies thinking about that, but there is so much going on in the world. There is so much going on in the world in the technical area of millimeter radars, which we may not have led in this country so much. There is so much scope for the industries to come up in this region. the millimeter radar-based satellites which can find the debris. And so we need to find expertise resources and such other things for it. Also, not just the millimeter radar, because there has also been talks about how to find out plasma striations, and then based on plasma striations, how to find the space debris. This is also a deep technology area. We are talking to the Indian Institute of Astrophysics to look into this and then handhold us. Number 3, development and archival of and management of comprehensive and iteratively updatable database. Now we all know that the database that we have of about some 30,000 odd objects coming from the US Space Command. So we need to have our own database. We need to have transparent database which will be available to everyone. And that is what the UNOOSA just now mentioned about, right? And so there is a large need for India to have its own indigenous database which can be shared by all the operators and all satellite people in the country in the future, in the industry in the country. 4th is the leadership in AI and machine learning for autonomous collision avoidance. Of course, we can use the millimeter radar technologies in this, but this is also a large area which is one of the foci of Nabhah Foundation, along with all its elements. Exploration of judicious and effective space debris mitigation strategies and technologies. We have been talking to a number of people who are in the domain of building space robotics. There are operators in the country, there are dreamers in the country who want to build space robotics, and then Nabhah is trying to handhold them and bring resources and expertise for them too. Lastly, the leadership and advocacy in the regulatory regime, because you all know, I just mentioned already, that there is a need for a number of initiatives in the country as well as abroad. We do not have a space debris convention, which is needed. Of course, there are some people who are working on this region who are also on the stage. They might be talking more about that. But it's important that we have a very strong regulatory framework for which Nabhah is also trying to build support in the country. And there are a number of things like Space Traffic Management Organization, SMTO, which is also supposed to be part of the regulatory network, regulatory framework, and whether we should have orbital taxes or that kind of a regime, what kind of a compensation regime that we have, what kind of evaluation we should have for space services and space assets, and whether we should be following the ISO 24113 and reviewing it, first of all. Because there are, in many other industrial operations, we do have standards. Even in space, we have ISO 24113, but that is still left to the conscience-driven organizations to follow it, but that is not a law at the moment. And so there is so much of a gap, and there is so much of possibility within the regulatory framework which we want to establish in the next 3-4 years or so. So we have a long list of how exactly we will be doing. We have got a roadmap of all. Maybe on some other occasion I will be talking to you on these matters. But ladies and gentlemen, as we all say, the time is of essence. And it's very important that we do this in a very fast manner, because the speed of progress, speed of building dimension of space debris issue is very large. It is not so easy to handle that. And in this country, we have always had hope. And we have always said, hum honge kamyabi ek din. But unfortunately, that ek din we have not defined. We have not given a date for that. We have never said hum honge kamyab next month on 22nd of April, or something of that kind. So that is one of those biggest drawbacks in addressing any of these big issues or big dimensions, which require huge human effort and national convergence and probably international convergence. So with that, ladies and gentlemen, I want to say that we are building an action plan on the platform of SIA and Nabhah Foundation. In the next few months, we want to make rapid progress with timelines and with the right kind of people, right kind of organizations coming together to address this huge, humongous problem. Ladies and gentlemen. Yeah.
Good evening to all. Our dignitaries on the dais, ladies and gentlemen. Yeah, I just actually, we had a very good message from Director UNOOSA, Aarti. Actually, she is a very close friend of me. We had many times discussions about what she said is right. Many years, decades, we were discussing same thing, same item, the threats from the space, active debris removal, IADC guidelines, UN guidelines, then long-term sustainability guidelines, in the international collaboration. All these things are discussing last 3 decades and mainly last 1 decade. In all international fora, we are discussing same thing. No concrete actions, no concrete products, no legally binding instruments. Only we are looking with the best practices. Again, we are talking about best practices. So what she said is perfectly right. Now, if I see chronologically, I just want to tell first what India is doing. She was also telling, India has to take a lead. India has to become world #1 in this aspect, in this sustainability things. In 1995, that is exactly about 30 years back, when we started, India started, ISRO started working on space debris. I was a part of the team at that time, 1995. There was about 4,500 objects catalogued by US Spacecom, US STRAC at that time, now US Space Command. They have about 4,500, more than 10 centimeter sized objects they have already catalogued at that time in 1995. There itself we thought as there is a concern, so we thought we have to see our satellites, whatever the satellites are there, how to safeguard them. We had some software and we started working on it. We started COLA also. In 1996 we joined Interagency Space Debris Coordination Committee, ISRO. We joined there. That is 1995. In 2002, when our PSLV rocket body, PSLV C3 test rocket body fragmented in space in December 19, 2002 December 19, it generated about 360 fragments of size more than 10 centimeter. At that time, we started working on the debris modeling aspects. 2002 December 19, PSLV C3, PS4 fragmentation in space. It's about 670 kilometers, 700 kilometers. At that time, the number of objects, actually, in fact, I started my PhD work in space debris in 2002 with a PSLV rocket body data, okay, fragmentation data modeling. At that time, it was about 8,000 catalogued objects were there, 2002. When I completed my PhD in space debris in 2005, number of objects has gone to 10,000 catalog data. Okay, 2005. So 20 years, 25 years, actually I am strongly working in this area. 30 years, but in 2000 onwards I was totally working in this area of space debris. In 2011, when I took over all the debris activities of ISRO in my division and under my leadership, the number of objects were about 16,000. Okay, the growth we have to see it. When 2019, when ISRO decided to make a concerted effort, wanted to make a directorate to take care of all debris activities in Bangalore. So I became the director of that directorate. At that time, number of objects were about 18,000, 20,000. Right? Then we started building up our own facilities and international standard facilities. And 2022, we have established one IS4OM, that is Indian ISRO System for Safe and Sustainable Space Operations Management in Bangalore, ISTRAC. That in 2022 we are dedicated to the nation. Now in 2025, if we see number of catalogued objects by US Space Command available publicly, actual number will be different. It is about 29,000, 30,000. That is the growth. In fact, actually, as per ESA, what I was telling, about 50,000 objects more than 10 centimeter size are available. It's there in the orbit. But we get less only, because some of the things, as you know, there are many objects, classified things which are not known to us. So that is the one part. Then India, as said here, we are leading. In 2019, Aarti was telling, UN COPOS, UNOOSA, we have one long-term sustainability, 21 guidelines are declared by UNOOSA, 2019. And 2021, actually India took over as the chairman of that committee, LTS Working Group 2, Dr. Uma Maheshwaran. And that was actually implementing the 21 guidelines. Okay. So last 3 years, UN COPOS, UNOOSA meetings, I am attending as Indian delegate regarding the sustainability. About all UN COPOS, that 2 weeks time frame, we are attending all the things where everything is coming into picture. Again, same, every country will come and tell what are doing is same thing, same status. Only number of objects will grow. So day by day number of objects growing, but the other things are same only. Active debris removal, yes, active debris removal is there, on orbit servicing is there, best practices. Now only one change I can see, that from Earth orbit to lunar orbit, now discussions have started. So we have a committee in the UN COPOS now to discuss about the lunar orbital debris mitigation and other things, okay, sustainability of the lunar orbit and cislunar orbits. This is what is happening. But there are now after that again, now people are telling new guidelines for LTS. So first of all, we have to implement that guidelines. All the member countries, member states need to implement those guidelines, and those who know, experts in this area, many countries are there, Japan is there, America is there, India is there. These people have to teach, give other countries how to implement these guidelines. One thing is, if you see IADC guidelines, there are 7 guidelines. That is 1990s, 2000 it is actually drafted. 2007 UN has published it as UN guidelines. Later, IADC is also working on many guidelines now. Actually, from 1996 we joined. From 2011 onwards, I was the leading IADC in India, for India. Now, we brought forward few new guidelines. Some already existing guidelines we have changed a little much. So, revision has come. Now also it is working on that. And mega constellations. What are the guidelines to be given for mega constellations? You know, IADC is the first committee which brought one small document on the mega constellation. What are the guidelines to be followed by the mega constellations? There we said, IADC said, less than 600 kilometer. If any mega constellations are required, please put it in less than 600 kilometer. Don't go for, at that time there were, even licenses were given by FCC for 1100 kilometer, 1400 kilometer. We said less than 600 because we said ballpark number of 25-year rule. That's all, nothing else. If less than 600 kilometer we put some body, 25-year only it will be there, otherwise naturally it will decay. So similarly we suggested, if any constellations, if we are putting lot of things, don't put it directly to its intended orbit of 550 kilometer. Now SpaceX has populated 550 kilometer orbit with thousands of objects, you know. So instead of going directly to 550 kilometer orbit, why can't you do it in less than the 300 kilometer orbit? All testing. Make sure that your satellite is working perfectly in the low Earth orbit, 300 kilometer. Then if it is perfectly working, you raise to your intended orbit. India, that is following. SpaceX is following that. So many objects which are not working, it will decay fast. To 300 kilometer, maybe month-wise, it will be coming down. So again, active debris removal. Now presently, UN COPOS also, we are discussing about active debris removal. You know, anyway, IISL people are there. They know it is a very big, complex situation for active debris removal. As far as the policy is concerned, as far as the funding requirement, expenses, costing coming, as far as the legal bindings, strategically it is very important thing, active debris removal. If accepted internationally to do, anybody can active debris removal, it is not possible, you know. Self-defense is one of the words people usually say that, and I can tell that a satellite is always harmful to me, I can go and capture that one, if technology is accepted and it is matured now. Yes, Japanese astroscale is there. They are doing active debris removal techniques, and I found that some startups are coming in India also for that. The space debris wise, mitigation is the one of the presently also one of the best practice we can do it to avoid any collisions, to avoid any destruction. And IIDC, one of the guidelines says anti-satellite test should not be there, you know. If it is to be done, it should be done in less than 300 kilometer, or long-lived debris should not be there, fragments should not be there. So, lot of things internationally being discussed. Now I understand that there is a working group, subcommittee for space traffic management in IAF. There is a working group of space debris, working group in IAA. There is a study team, big study team in ISO. IISL also studying. So there are many international bodies taking up. Now I understand ITU has taken up. ITU has a big way, they are coming up for framing the guidelines or instruments. So lot of things are happening, but final aim, like Aarti, Director UNOOSA is telling, is there. Many people may be repeat. Whenever a sustainability comes, as problems are there, but there are no actual solutions coming up now. So it is better to have concrete decision making, concrete activities, to have concrete products, concrete actions. Now ESA has come up with a zero debris charter. They have gone in a way that many countries are going to sign that, many industries are going to sign that. It's a very good move. And last year, 2024, actually Interagency Space Debris Coordination Committee, I was chairing, India as representative of India, I was chairing in the IIDC. And our IIDC annual meet we conducted it in Bangalore. There India declared, ISRO declared, we are going ahead to the DFSM, debris free space missions by 2030. Means today onwards, 2025 January onwards, whatever satellite we are designing, we made sure that provisions are there for post-mission disposal. Probability of successful post-mission disposal is 99.95%, and all of our satellite by 2030 will comply with the DFSM rules. DFSM has some 6 areas where it tells that we will follow that, which will help us to sustain a useful space, outer space for spacecraft operations and contain the space debris growth. So we are following very strongly, and we already told Indian industry should follow that DFSM, debris free space mission, by 2030. For that, one of the component is observational facilities, which is what in fact India lacking. That is what we are trying to build up that. It's a very costly affair. We are trying to build up that space observational facilities, and thanks to our space sector reforms, many startups have come up, like Digandhara. So they are coming up and they are contributing to the sustainability of outer space activities. Thank you. Thanks a lot.
Good afternoon, everybody, distinguished speakers, distinguished audience. Thank you very much for having me on that panel. My name is Kai-Uwe Schrogl. I am the Special Advisor for Political Affairs in the European Space Agency and the President of the International Institute of Space Law, which is a non-governmental organization. It's so difficult to speak after you, Dr. Kumar, with your experience and your understanding, your wisdom and insight in the space debris problem and the space debris issues. Our paths already crossed, not only in IADC, where I also participated in the very early 1990s, and also then in the UN Corpus, and most lately also with the Zero Debris Charter of ESA. I would, of course, I cannot add anything to the outline you gave on the history, on the practices, as well as on the content of what has been performed during the last 30 years indeed. I would like to present to you simply a a glimpse of optimism. We are used now to say and even to lament, well, there is no binding instrument, oh, we are failing to grapple the issue, we are behind, it's too late, and a very, very negative attitude. I would like to bring optimism in that I would first of all say, since the past 30 years, also thanks to your efforts, to the efforts of ISRO as an important member in IC, as well as in the international non-governmental organizations and in UN Corpus in particular, we made big, big steps. We are far from just producing paper. We are acting. We are already acting for so many years. Imagine when I started in the 1990s in UN Corpus to deal with the space debris problem. It was not even on the agenda at that time properly. Delegations even denied that this is an environmental problem because they thought, oh, if we would admit that it's an environmental problem, we would have to act as we have to act on environmental problems on Earth, which would bring us into a situation, oh, we have to do something. At that time, they just wanted that this problem is negated, it's kept under the carpet. But then the agencies, in particular those who have launching capabilities, started to really work on it, analyze it, and act on it. We don't have, that's true, any binding agreement. We only have guidelines with the lowest possible, let's say, legal status. But states are already acting on that. States are guiding their activities in the direction of, just as an example, the passivation of upper stages. We haven't had that for long. It's not binding. It's just done. And this is a sign of hope. It's also a sign nowadays that we look at areas like environmental policy, and Chairman, you presented that at the outset with examples. All the regimes and the treaties, the binding treaties in environmental policy are now examples we take into account. We also look when we try to find out, would there be possibly a fund for debris removal, then we explicitly point out that we draw lessons from the Paris Agreement, for example. So things have changed considerably. The mindset has changed. The readiness also to act has changed. And this is a good basis to build on. Now, of course, and this is why this statement, this declaration is very important, we should not stop in reminding, driving further, and aiming higher in this respect. ESA has presented the Zero Debris Charter in line with the zero goals we have in environmental policy. Many governments as well as agencies, industry agrees to that goal. Now it's not an ESA activity anymore. They sit together and say and think about how to achieve these goals, how then to take practical actions, and this statement will certainly give an additional push and help in achieving that. So the attitude, and this is sometimes as important as the diplomatic status of debates, the attitude of the stakeholders is there. And they are acting, the stakeholders are acting. And this is where we have to simply support not only with governmental policies, but also with recognizing what they are doing. You have a chapter on social responsibility. I very much like the term social responsibility, because when you see now debris is falling on Earth on a practically daily basis a few weeks ago in Poland with some effects. This is also a social issue now, an individual issue by citizens around the earth. This is something we also have to acknowledge, and it is acknowledged. So encouragement, this is what now has to come from us also, those who are in the community, who are driving also the thinking, and the further extension of issues. And this is something where I am as concerned as about the debris issue itself in outer space. Because when we said, deorbit your satellites, and now everybody is doing that, and we will soon have not only one, but a few mega constellations. And when they all deorbit their satellites, it will be thousands of satellites which are deorbiting and which go through the atmosphere. What does that do to the atmosphere? There will be damage. There is already damage. These are the things which are taken up by the Zero Debris Charter, which are now taken up as they have to be taken up or should have been taken up 30 years ago when debris was only slowly getting on the agenda. So this is our task, to look ahead and to take into account now what we are facing then, what will be a real and big problem in 5 or in 10 years. So again, we came a long way from denying that there is a problem, that it is an environmental problem, to understanding what the problem is, to acting in key areas, but then also to encourage the actors what they have been achieving so far to extend to these new and additional areas. Thank you very much for your attention.
Yeah, so once more good evening. Thank you, sir, for the present. And I would like to announce that the Axiom for Crew module successfully docked with ISS. And it is understood that by our time, 7:05, Shubhamshu Shukla will be entering into ISS. Okay? So I think there is some video they are going to play. We can see that video.
Raju, can we go ahead with the next talk, and after that we will have it when it's ready? Yeah. Ms. Sonia?
Yeah, please.
Good afternoon, everyone. Thank you for SIA for inviting us to this very interesting panel discussion. My name is Aya Iwamoto. I'm Vice President of Strategy and Policy of Schrogl Japan. If for some of you may not, my company, Schrogl, is company headquartered in Japan with global footprints. We have office in US, UK, France, and Japan. I belong Japanese subsidiary, Schrogl Japan, and we are trying to develop a technology related to on-orbit servicing, or sometimes called in-orbit servicing, or ISAM in US, but trying to develop this technology to realize space sustainability issues. Is that okay? So what I was going to say, I was thinking what I should share this today. So my company is 11 years old now. When our founder and CEO Nobuo Okada founded our company, he wanted to create a company to address the issue of space debris 11 years ago. Many people advised him that he is reckless and not to go into that business because, one, technology is not available for private companies. Second is there's a legal issue, policy issues, that there's so many unclarity, unpredictability in the policy area. And also the third one, which still many people ask us, who is going to pay to remove space debris? So he decided to create the company, Schrogl, with approaching three aspects of the issue: technology, policy, and business. Sorry, excuse me. As for the technology, we, Schrogl Japan, together with JAXA, we launched a satellite called Address J1 satellite this year, and our satellite successfully made a close approaches to the H2A upper rocket body, which is a debris launched in 2009 at the altitude around 600 kilometers in Q. Made a close approaches to 15 meters as well as 115 meters. And now we are developing another satellite to actually dock with the H2A rocket body and try to remove that from the congested orbit. So technology is being developed, and I know that ESA is also developing technology under the Clear Space One, and some of the Indian company that I have joined with the same panel also trying to develop technology. So technology is now being developed. And as the area of policy, as Ms. Holla-Maini from the UNOOSA mentioned, that New Zealand, Japan has come up with the new sort of guidelines specifically made for on-orbit servicing or active debris removal. And I would guess that UK, New Zealand, and Japan is trying to lead the discussion in the UNOOSA global dimension as well. So there, compared with 10 years ago, through the national regulation, I think that at least for on-orbit servicing providers, the quality of the legal regulational aspect has been improved now. Having said that, still there are areas that needs to be addressed, particularly with on-orbit servicing that relates to the international aspect. Currently, our mission, Address J mission, is conducted between the same Japan registered objects, so there is no international, aspect between the two objects. But if our satellites, for example, would like to provide the service for Indian satellites, there will be many issues that legal issue that needs to make it clear. So there are still areas that policy needs to be addressed, and also we need the more momentum or awareness that space debris needs to be removed. And thirdly, the business part, which is the most difficult part. Still, space debris is basically the so-called tragedy of commons. Nobody really wants to pay for that. Even for the future satellites, I think many operators would see to spend money on sort of space sustainability part as additional cost. So we are trying to approach these issues. We think that space sustainability practice needs to bring the business value to the space operators. So we are trying to think in a way that if you think about the industries on the ground, or if you think about your car is developed and manufactured in automobile company, it's sold through dealers, and you get the car and you drive it. And if it's broken, you take it to repairs. If your gas is running out of it, you go to gas stations. And if you want to buy another car, you may resell it. Sold cars may be used by someone else or recycled some way. So there's a post-servicing industry for the ground, services on the ground. We think that on-orbit servicing or RPO technology in the space there is no such post-servicing industry, because once it's launched in the space, there's nothing you can do about at space. So basically, satellite is designed, operated for single use only. But with the technology, RPO, we believe that it might be possible to create a post-servicing industry for satellites, we hope that will bring a benefit for actual economic benefit for satellite operators. What we are trying to do is basically to build another layer to the history of space agency has been built up on space debris mitigation and other activities. But hopefully that we can provide commercial solutions on space sustainability issues, so that space sustainability makes sense for everyone for this one. And before closing, I would just like to touch upon that Astroscale Japan is working with several Indian companies that who are also interested in space sustainability. Gigantra is one company, and Bellatrix, we are working together. So hopefully that we would like to expand the collaboration in this area with the Indian industry as well. Thank you so much.
We would like to introduce Benicia slightly differently, because most of the people sitting here have experience in space, whereas Benicia is the Executive Director for International Institute for Waste Management on the land. And she wishes to explore the possibilities of using the same techniques that she uses on the land in space. And so this is her first day into space, and then she's foraying into a new area. So ladies and gentlemen, Benicia for you. Yeah.
Thank you so much for the introduction. Yeah. Good evening, everybody, on the dais and off the dais. This has been, the entire day for me has been such a Pandora's box, because there's a lot of things which has come up, which I was always trying to draw a parallel between the land waste management and the space waste management. In fact, there are a lot of parallels, but at the same time, there are a lot of differences. So I've just tried to put in certain things, especially from the practical side of it, because I know there are certain guidelines, but I have been looking at it from a very different angle for the entire debris waste management and the sustainability angle. So the first time, everybody knows waste management is there everywhere when you, so space also. However, the first time it actually struck most of the common man. I know here most of you are from the space sector, but in the vast populace, what really stuck was, especially in India, was when Chandrayaan-3 was launched, and they had to delay the launch by 4 seconds, and that was actually to they were trying to see that the debris moves away, and that was to thought that. So if it was not done, what would have been the consequences? We would have lost about 77 million US dollars. So, you know, that's the kind of perspective. In India, when we talk about waste management, it is always, or any part of the earth, when we talk about waste management, we always relate it to environmental impact, we relate it to health impacts, which is sometimes, you know, not really taken. Yeah, it is there. You know, there will be heavy metal poisoning. So that also people look at it saying that, of course, it's not immediate. So, you know, we always need some kind of a plague to be really awake and then to come out with a solution. However, when it comes to space waste management or sustainability in space, it is directly equivalent to money. And when you see the dollars in front, I feel it is easier to convince people. However, the challenge here is the technology, and the challenge also is the money, because it's very, very expensive. So now that is the reason. The first thing which came to me, I mean, why is it important that space waste management should be taken up? There are 3 reasons which I have come up. And the first one is regarding the critical minerals. And especially this, I would say for India, it's very, very important, because we have many minerals like lithium, nickel, cobalt, rare earth elements, graphite, beryllium, tantalum. So, you know, there are an array of critical elements which we are very, very conscious about, because even if we have to start making the satellites or any kind of space equipment, we require all these minerals and all these elements. So that becomes a very, very critical substance. And when we are trying to see what is the parallel that can be drawn, is one is we have to look at it from the inverted pyramid. First of all, how much can you reduce the waste? Because this is the principle which we say circular economy. So how much can be reduced? Now that I'm sure most of the industries are doing, trying to actually reduce the use of material to such an extent that you know, without it you cannot do. So that's something which is already being done. The second one is about reusing, which is also being done now, because there are several industries which are trying to use at least the launch pads and other things, which is again a good system to be practiced. The third one is recycling and recovery. Now this is very critical, because especially here what happens is once it goes out, you cannot bring it back, because that becomes again expensive, and when it is coming also, half the thing is lost. So now I know that there are certain industries in the world who are trying to work on the principle, because theoretically 60% can be recovered if it is brought back to the earth. So that is something, I mean, this is what I read, I hope I'm right. So if this can be achieved, then we have a good chance of recycling and recovery. And India is the leader in recycling in the world. So this would be a very good opportunity for most of the industries here, because we have a robust system of recycling in the country. So this could be a very good opportunity for many of them. So that's the first aspect. Now I was trying to find out what is it when it comes to numbers. We call it inventorization. Sir was mentioning it was cataloging of the waste, the debris. Now this is definitely a challenge, but we have learned many things of inventorization even for waste in our country. That is still a big challenge, because data is something which the industries will not divulge. And how do we do that? There are thumb rules, and I'm sure we can also have some kind of thumb rules for every kind of equipment which is put out. And that is a very good way to start, because for hazardous waste management from the industries, we had this issue. Even today we do have it, but we have developed certain kind of pattern in which we can actually do this. And this is the first step, because unless we do this, we will not be able to get a proper waste management. So across the world, now this is something which can be done. Now again, another parallel, we do have international regulation called the Basel Convention, where this is used, where all countries, they are having this kind of a system. I'm sure we can also try this out with the space waste management. Of course, there will be certain challenges, but of course, whatever is going from the earth, we know what it is. And with that, we will be able to do some kind of an inventorization. 60,000 tons to almost 12 lakh tons is the kind of debris which is existing currently in the space. So as you actually talk about it, in terms of quantity, when we see that, even Delhi has less than that when it, the waste that is generated. However, it's not the kind of waste or the quantity. Here it is the challenge is to bring it back or to dispose it there. The next one is about the space waste management in terms of logistics. That's what we call it, logistics management. However, here we say tracking. Now again, in terms of tracking, we have several AI tools and all that, the manifestation. There are legal systems which are established in terms of tracking. Now here, for waste management, the debris management in space, there are technologies which have come up. I was just looking at certain possibilities, which is the harpoons. This is to snag and also deorbit. I'm sure you are also doing it. Is this a technology? Okay. So that's one possibility. Then there is also the nets, and that was very interesting because we have now got technologies of nets to actually grab the waste, which is something very similar to the ones which are being done in the oceans for the plastic waste management. That was again very interesting, but here there are much more sensors which are involved. Then we have robotic arms. Of course, this is again something which India also, there are some startups which have this. The laser technology, there are the tethers. So there are some few technologies, and I was going into the details of it. It's quite interesting, and this is again another possibility of bringing back the waste, and which we can recycle and reuse. Maybe it is in the infancy stage, but there is definitely a possibility. The next one is about the space equipment, and which contains the toxic material. Now this, I'm sure, is also being looked at in the laws, which you are having already, the guidelines. But I am again trying to have a kind of a parallel drawn here, because we have ROHS, and there was a agency, a government agency with whom I worked to find out about the antimony waste disposal. So this was while we were working on the hazardous waste management. Now these are certain, there are many hazardous substances which are used also in the space waste management, the space equipments, and that is also having health impacts, especially because many of them also get released while they are in the space stations, which might be harmful, especially the fire retardants which are used. Now, ROHS is an system or the guidelines which is used world over, mainly to reduce the toxic substances. However, when it comes to the space equipment, there is another guidelines which is being issued. Mainly, it's called the JSTD 001, which is used to see that the sustainability of the substance is higher and it's very robust. So when it comes to that, what happens is you use more of the heavy metals, the soldering, and these kind of things, which means you are increasing the hazardous substances. So there is a clash between the hazardous waste rules and the space usage. So these kind of contradictions are also being looked at. However, this is the third aspect, which is mainly to look at what kind of toxic substances are there, because sustainability means we have to reduce that. And all of us know most of the countries which are working on the space technology are the ones who are party to the sustainability goals. So the SDG 18 is something which directly applies to all our all this sector. So I'm sure if we have to adhere to that, again it becomes an issue, and we really need to look at it. I think that is what it is. So I hope that by 2027, 2030, we will at least have some kind of an implementation, and definitely technology is the key to it, and because the will is there. So I wish that in 2030, when we are all here, we would at least have some kind of implementation guidelines to work on. And thank you so much.
Hello everyone. First of all, thanks a lot for having me. I think already a lot has been said. There is very little to say, but I think I must say that I'm not from a policy background. I'm an engineer by background, so I'll try getting a tech angle. And I always like to say, discussions, philosophies, deliberations have to conclude with simple sentences, simple conclusions, and action items. So with that thought in the background, overall space traffic, I think it's space sustainability. I think it's best looked at if we look at in the lens of traffic. So imagine a few centuries back when the first vehicles, first cars by Benz or so on, went on the roads. There was nothing, they just went. But today, if you have to buy a car, it has heavily regulated. I mean, I think if you are buying a car, I think about 20% of the cost is coming from regulations. And if you have to take it on the road, you have lane disciplines, you have traffic lights, there are cops to enforce that and everything. Right. A similar transition is something happened in the aircraft industry. I mean, 5 decades back, I think if we had just a plane lying around, we can just take off. But I think the authorities today wouldn't like people randomly, conquering the skies. They would want that regulated. And in fact, if you are flying, you have to sort of file your flight paths, take permission, authorizations, and so on. And both of these agencies, be it on roads or on sky, the regulations didn't exist on day one. The sustainability didn't exist on day one, right? It came in once certain accidents happen, right? There were accidents. People lost their lives on roads. People lost their lives in air when two aircrafts collided, and that's when these policies came up. These infrastructure to manage the traffic, both on roads and on in our air, it came up. But sadly, I think space is not a place where we should be waiting for debris to be raining on our head or people dying in space with collisions for us to, act on the sustainability regulations. Because I mean, even if those kind of activities where loss of humans or loss of spacecraft happens is already something that's very bad. But activities like that leave a very lasting impact in space. So there have been countable collisions in space, but I think they form almost 30% of space traffic today. Like I would say, I think 3 or 4 collisions in space that have happened, and they are accounting to 30% of the traffic. So that is the nature of space. So regulations have to come first before the accidents. So I think that is a constraint of operating in space domain. And we have already reached today with respect to space traffic to a point where as a human society we stop launching all our spacecrafts. That means we stop this activity and let the space traffic be as is. The amount of space traffic is self-sustaining. So traffic is self-sustaining. That means the number of objects in space will continue to increase even if we stop. I think the first actionable step that we'll have to take is to reverse that, right? We do what all it takes, be it tracking, be it maintaining custody of objects, building regulations, policies, enforcing them, doing active debris removals. All of this to just get to a point where if we stop space activities today, the number of objects in space or space traffic don't increase. I think that's a very, I think, realistic goal that we all should be working towards. Anil sir started off with his presentation where, his discussion where in 2000s, where he was part of the OG space sustainability group in the country, and how breakup of a PSLV stage sort of triggered this activity. So first steps, I think, is something that has already been taken in this direction, and in fact, the work done by Kumar sir and group is where I think company like Digantara is here today. We see them as pioneers in the space sustainability industry, and are the people who have set the stepping stones for space sustainability in India. And if you look at again aircraft industry, setting sustainability is not as difficult as it seems. So while the Second World War was ending in 1944, 45, not the best time where you would see superpowers would want to work together. But during that period is where a set of feasibility studies were done in US by the leading powers, US and Russia included, right? And in a year's time frame, sustainability guidelines for aviation were agreed. And in a year from there, it was implemented very formally called through an agency, which is now what we know as International Civil Aviation Organization, ICAO. And in terms of actionable steps, I think we are just what is left to be done is, I think, technology is being built both for tracking by us, remediation by Astroscale, and there have been enough deliberations that have happened on policy making. I think what is left as next step is one country to take leadership in figuring out the feasibility studies, doing a year of feasibility studies. I think that is what it would take for creating a space equivalent of ICAO. But the biggest challenge here is whatever flies in air, we don't consider it as militarized, but anything and everything in space, be it even a rod or a stone, is considered militarized. So I think this is the main challenge that is hindering space sustainability efforts, and considering the background with which Indian space sustainability efforts, and in fact largely the space program is there. I think we are better suited, sir, and you yourself are a director now. I think it's an opportunity where we should really think if ICAO was created in the US, space ICAO, can it be created in India? Can we do the feasibility studies for a year, get all I think almost all countries are comfortable traveling to this part of the world, and essentially having a dialogue, having a feasibility studies on civil space sustainability, identifying, differentiating between what military space is and what civil space is, and leaving the military guys do what they want to do, and the civil space sector being regulated in terms of sustainability. I think that is the only way forward, as per I see very realistically and very candidly. And I think we have a lot of right ingredients, right people, and right kind of mindset to kickstart it. So yeah, I think I'll leave the audience with this thought of initiating a set of feasibility studies for space sustainability.
I think having not been formally a part of this session at the beginning, as listed, I'll speak from here only. Is it okay? So, I think a great initiative by NABHA, SIA to formalize, our commitment for making space more habitable, sustainable. I mean, 4 years, SIA having positioned themselves to in such a position, such a situation where they can address difficult topics of the kind is indeed great. And in fact, we have all heard Aarti Holla-Maini having spoken about the need for sharing data, following some discipline, all spacefaring nations following some discipline and commitment to keep the space and outer space clean. And those things have been well addressed. And UNOOSA and IISL and IAF are the larger international bodies who are championing the cause of space sustainability. And, there couldn't be a more befitting situation where Dr. Kai-Uwe himself, who is president of IISL, is amongst us today. This will be a great milestone in our initiative to take such an initiative. And Anil is here, Anil Kumar. He represents ISRO in UNOOSA for the last few years. And he is well aware of the efforts ongoing there. Ranjana ji is sitting there. So with all this, just as an anecdote, I would like to recall after, the Earth Summit in Rio in the early 90s, in India, we started a movement called Integrated Mission for Sustainable Development. That time, the food productivity in India being less than 1.2 tons per hectare, and how best we will continue to feed our population. 1/6 of the global population living in 2% of the global land area was great concern. And India really became cynosure that about 20–25% of land mass was covered under Integrated Mission for Sustainable Development, primarily using space data. Okay? So we generated various layers using remote sensing data, space data, and synthesized everything and prepared actionable, locale-specific actionable plans which were used by all states, all central ministries, and from 180 to 220 million tons of food grain that we were producing and which was good enough for feeding our population then, this year is going to be a bumper harvest with more than 280 million tons being produced in the same 156 million hectares. So though situation looks outwardly bad, that is the success story of having used space for some kind of sustainable development on Earth in Indian landmass. So those days, to synthesize all the efforts, we had brought out a book. Dr. Sudharshana was with us. We were colleagues in ISRO. He has extremely good writing and editing skills. So he had put below the title, Back to Future. You see, same analogy holds good here. If we want to make sustainable space and outer space sustainable, and we being, though our numbers are small, when you take space objects, the numbers of space objects put by India up in space is small, we are one of the 4 or one of the 6 major spacefaring nations in the world, and we are into the game of all aspects, building assets to, launching them to, maintaining them to, utilizing services emanating out of them. So what the Back to Future catchy title which Sudharshana gave to that book we brought out in ISRO, I think this is also something like going back to future. If we want to ensure that space is sustainable, maybe after 100 years from now, it will not happen so soon, we know. And morning, Dr. Kai-Uwe emphasized, he made, the last sentence in one of his slides was having very punching words which he didn't read, which he didn't utter. The future of space cannot be decided by billionaires alone, few billionaires. It was in his slide, but he didn't tell. Let me take the liberty. Okay. So, it should be whatever we do, the discipline, the policy guidelines, the rule should be same for everybody. But cleaning space is not easy. And in recent years, another dimension is added to space, too much of focus on outer space, construction in outer space, and mining in outer space, using the resources in situ in outer space. All these are going to create debris much higher up in space. But LEO is indeed a big worry now, and there was also a good session in the morning with respect to communication satellites. The advantages, disadvantages of LEO versus GEO were being talked about, and we are mostly in the GEO orbit, India. Anyway, that apart, I don't want to take much of time, so extremely good thing, and personally I am honored to be a part of this momentous occasion with Dr. Kai-Uwe Schrogl, an old friend of mine from 2010 onwards, and Anil is here representing ISRO, and Sudharshana, he left ISRO, and 1.5 decades or so he spent in UN, mostly in the UN Security Council, again addressing critical issues of war-affected areas in West Asia. So when he came and told me that he wants to move a company with, of course, other friends of us, a not-for-profit initiative, Nabhah Foundation, basically he's talking of creating authentic and usable database at this point of time. And data which is not shared by everyone, which Aarti also mentioned, director of UNOOSA, everybody doesn't share all the data. But data is today trackable, mappable, assets are being built for that. So towards that direction, the SIA-Nabhah initiative, or Nabhah SIA-India declaration, is an extremely important step. So I would request, Sudarshan and Rajiv probably to come forward. Anil is here, you may decide. And please tell a couple of words and formalize. So we will indeed make this occasion momentous and move further. There are people to guide us.
So we started with paper to practice. So let's start with the practice and let's get on with it. I'd like to invite Dr. Subbarao with us while we are releasing this declaration, Mr. Anil Prakash and Dr. Ranjana Kaul, please. Could you please join us while we are doing this release of this declaration?
Ladies and gentlemen, closing this session, in fact, it's been a very long session, but so I do not want to take longer. But since we have released this declaration, I just wanted to say a few words about this. The declaration is basically a commitment. A copy of this will be distributed to the people later. So it has a preamble. I will not read out the entire text, but I will just mention to you what exactly is contained in this. A preamble which recognizes the leadership of ISRO and then the leadership of a lot of institutions which have brought the situation to such a level that we can take off from here. So foundational efforts have been made, and so we are acknowledging the foundational efforts and then the impetus given by all these different institutions in this sector. And then after that, it describes a rationale as to why exactly we need this particular thing. The rationale very clearly talks about the dimension of the debris problem, and then how it is very important for us to leapfrog into this and then take this forward at the speed at which the situation is changing. You know, I just mentioned to you about the climate change, the speed of climate change. This could be perhaps faster than that. And then we are talking about the zero debris protocol, etc. But there is also a zero emission standards, zero emission milestones in climate change, but still, you know, we are not reaching there with all the efforts, but here, not much of efforts have gone into that, but so it requires a lot of efforts in order to get into this sector, and then even establish milestones. That's what the rationale says. And then it talks about the national convergence, the necessities for that, why exactly we need the national convergence. Otherwise, it is not possible for a single institution or a single entity to carry out this enormous problem. And then we have also established the action plan, the 6 foci which I mentioned during my talk. So in a very short manner, in a succinct manner, we describe the action plan which we want to take forward. And finally, we just call for the social responsibility of creating awareness, and also for the socially responsible organizations as well as initiatives like CSR to get into this framework, because the CSR in this country doesn't prioritize space debris at the moment. I have spoken to InSpace. Even in the InSpace charter of priorities, the space debris is not there. So space debris is not recognized to the extent to which it has to be. So we are talking in this declaration the need for social responsibility and creation of a conscience. So we have to be the conscience keepers in this country with whatever abilities we have in order to address this. And finally, ladies and gentlemen, we take this opportunity on behalf of SIA and the Nabhah Foundation that we have this deep aspiration to call 26th of June as the Space Debris Mitigation Day. Okay, so, yeah. So from now onwards, through the declaration, we will celebrate, we will come back to you, we will talk to you, and then every 26th of June, we will give you the report card of where we are, and SIA and the Nabhah Foundation will work together on this with an action plan. With an action plan also, we will come back and report to you as to what exactly we did, how we brought together the institutions, experts and resources and all that thing. So that is the declaration, that is the commitment, and this is our resolve, ladies and gentlemen, to which you are all a party. Thank you very much. Yeah.
Thank you so much to all the esteemed panelists. That was great and indeed session. I would now like to facilitate our panelist over here, and I would request Dr. A.K. Anil Kumar to do the honors, and I would start naming them in no particular order. First, we would like to hand over the memento from SIA-India, and also Nabhah Foundation was kind enough to give us another memento, which is being placed inside the SIA-India bag. So I would start with Professor Dr. Kai-Uwe. Please, can we have some round of applause, please? He's the President of International Institute of Space Law and Special Advisor for Political Affairs, European Space Agency. Moving on, we'll go to Dr. Sudharshana. Ramaraju, who is the founder of Nabhah Cosmos Foundation. Then we have Ms. Aya Iwamoto, Director, Japan Space Policy, Astroscale. We have Dr. V.S. Hegre, former Scientific Secretary, ISRO and CMD Antariksh. Then we have Dr. Benisha P. ED, International Institute of Waste Management. And finally, we have Mr. Tanveer Ahmed, CTO, Dignayatra. Thank you so much. And to give the memento from SIA-India, I would request Mr. Anil Prakash to hand it over to Dr. Anil Kumar. And I would also request everyone to have a group photo. Please. Thank you once again for a wonderful session. Please stay back so that we can also announce the winners. Okay. Announce the winners for Call for Paper initiative. We have 3 winners for that, and I will start. I would like to now announce the winners. So starting from the 3rd position, we have Hirday Vyas and Lavya Satija, Indian Institute of Space Science and Technology. They wrote a paper, HIIDE SAT, Heat Island Infrared Detection Satellite. And they've secured the 3rd position. Round of applause for both of them. Please, can we have you over? Yeah. And can we please have Dr. Hegre on the dais, please, so that we can pass on the certificate to the winners. So can we have you on the dais, please? Can we have a huge round of applause? All right. Sir, can you please stay back so that we can announce the person who secured the 2nd position is Krishna Balchandani, Multi-Planet University, for the paper Neural Monitoring Systems for Astronaut Health Using AI. And I believe we have to skip this since the person is not here. But I will now move on to announce the first winner who secured the 1st position is Mr. Vinay Kumar Reddy for Reliastat Inc. for his paper Drag Sails for Passive Satellite Deorbiting in LEO, a sustainable and economical approach to space debris mitigation. And he secured the 1st position. A huge round of applause and congratulations to you. Thank you so much, sir. Thank you. Yeah. Thank you, ladies and gentlemen. Now we are closing the day, and I would request you all to please join us for another great round of day tomorrow, which is the last day for India Space Congress. And now we're closing the session. Thank you so much once again. Have a great evening.